Today we'll be taking some of our triangle vocabulary and relating it to various ways that you can measure where the center of a triangle is. So you're going to want to cut this out, but you can do that after you have filled it out. Pay close attention as you cut because the lines don't line up perfectly. They're very close, but they're not exact. So it'll fold up like this. You'll find this on the back side from the side that I originally showed you. So just a reminder that angle bisectors are line segments that go through a vertex and cut the angle in half. So the angle bisector goes through the vertex and cuts the angle in half. On the other side from there, you'll find this triangle. So this is a point of concurrency that is called the incenter. It's one of several different centers of a triangle. The incenter is if you take all of the angle bisectors and draw them out and then draw a point where they meet. That is the incenter of the triangle. So this is where the angle bisectors meet. The incenter is equidistant from each side of the triangle. So this point is exactly the same distance to here, here, and here, meaning that these three lines are congruent, these three sections. Next, perpendicular bisectors. Perpendicular bisector is a line segment that goes through the midpoint of a side and is perpendicular to that side. Remember that perpendicular means that it meets it at a 90-degree angle. So on the other side of this, we have this point of concurrency where the three perpendicular bisectors for a triangle, perpendicular bisectors, all meet. That point is called the circumcenter. Circumcenter. The circumcenter is equidistant from each vertex. So just like the incenter is an equal distance from each side, the circumcenter is an equal distance from each corner of the triangle. So the distance from here to there is the same as the distance from here to here and the distance from here to here, but those lines aren't drawn on here because these are the perpendicular bisectors. They go straight out to the midpoint of the sides. Now, a new vocabulary term that we'll talk some more about later this week is the median. The median is a line segment that connects a vertex to the midpoint of the opposite side. So like this would also be a median in addition to being a perpendicular bisector because it connects this corner to the middle of this side. And on the other side of median, you'll see our next point of concurrency, which is where the medians all come together. So if I draw the three medians for this triangle, where they meet, that point is called the centroid. So the centroid is 2/3 of the distance from each vertex to the midpoint of the opposite side. So that means that this distance from here to here, this point is 2/3 of the way from here to here. So if this were a distance of 3 total, this would be 2 and this would be the last one. Or if this were 6, this would be 4 and this would be the last 2. Whatever this distance total is, this is 2/3 of that distance and this is the final 1/3. And the same goes this way and this way. It's 2/3 of the way from the corner to the center, or the centroid, and then the last third is the way to the side. And then our last measure of a triangle center is where the altitudes meet. An altitude is a line segment that is perpendicular to a side of the triangle and extends to the vertex of the opposite side. So it's similar to the median, but you notice that the medians go from the midpoint to the vertex on the opposite side. These don't just go from midpoint. The main thing about these is that they are perpendicular. A median, you'll notice that these are not necessarily perpendicular. In fact, they kind of go off in different directions sometimes. So altitudes go straight up and down at a 90-degree angle from one side to the opposite vertex. And if you draw all three altitudes, the point where they meet up is called the orthocenter. So those are the 4 measures of center for a triangle. And I want to add one thing to this. And you can write this on the page where you're going to glue this in your notebook, but we're just going to make a few lines here. So let's say we have a line there, and there, and here. However you're drawing your lines through the triangles, the place where the 3 of them cross is called the point of concurrency. And remember, the circumcenter is where the perpendicular bisectors cross. I'm just going to put these down as a quick reference. The incenter is where the angle bisectors cross. The centroid is where the medians cross. And the orthocenter is where the altitudes cross. Two final vocabulary words. If we have a triangle, I'm going to try and draw this. A triangle with inside of a circle where the circle goes around it like this so that each point of the triangle is on the edge of the circle. Of course, I'm assuming this would be a perfect circle, and I didn't draw one, but this is called circumscribed, meaning that it passes through the vertices, the edge of the circle passes through the vertices. And then if I have a triangle and the circle is drawn inside in a way where the edges of the circle touch the sides of the triangle, that is called inscribed. Inscribed, where the sides of the triangle are tangential to the sides of the circle. And being tangent to means that they touch.